702.
The Naked Scientist.
Good afternoon to you, Dr. Chris.
Hello, how are you?
I'm fine, and you?
Well, I'm doing all right, thank you very much.
Jolly good. We've got lots of questions. Shall we just get straight into it?
Dive in.
Ava says, why do our immune systems not recognize our eyes? And we could go blind if they did. And could we go blind if they did?
Well, from the minute we are putting together our immune system, which actually happens during embryonic development as a fetus growing inside our mums, we have important structures which begin to educate our immune system. One of them is called the thymus, which is something which slowly disappears as we get older, but it's in the chest. And this is basically white blood cell school. And as white blood cells are formed in the body, they go to school in the thymus, and it shows them what your own body is made of. In other words, it shows them what not to react to. And any cells that go to thymus school and try to respond to our own tissues are deleted. They're suppressed, they're stopped from developing any further. So the immune repertoire that you produce is as diverse as it possibly can be to give it the best chance of recognising everything that nature may throw at you, except anything that could cross-react or be recognised as yourself. So in other words, the immune system from the get-go is programmed to tell self from non-self or friend from foe, to put it a different way. But that doesn't work in everybody. And for some reason, a variety of reasons, thankfully rarely, the immune system does occasionally turn on our own tissues, and you only have to look at people who suffer from these autoimmune diseases to see just how catastrophic that can be. And the common ones are things like rheumatoid arthritis, where the immune system attacks joints, and this causes damage, especially in the hands. It's most visible, but it can affect a number of different joints in the body. Also the disease lupus, SLE, where you make antibodies which recognise parts of your own DNA. This causes a systemic inflammatory syndrome. So thankfully this doesn't happen very often, but there are certain sites in the body that are regarded also as immune privileged. They're off limits to the immune system normally, but it can occasionally gain excess, and if it does, it can wreak havoc. And your retina in your eye is one place where that can happen. Also the testes. If you get damage to one, you can then get immune damage to the other, because once you train the immune system to recognise and attack a part of the body, it becomes really very good at doing it. So thankfully, again, very, very rare steps are taken by development to stop this happening, but sometimes it does slip through the net, and then we have to dream up other ways to control it.
Okay. Rod asks, as we all know, air is made up of nitrogen, about 80%, oxygen, about 20%. Is this consistent at sea level globally, or do the constituents vary relatively? Further, if the ratios are consistent, how does our planet maintain such consistency in the face of human intervention? In other words, industrial combustion, selective air separation processes, etc.
Well, the answer is yes. If we look at the proportion of the air that is each of the gases that Rob mentioned, they're roughly the same everywhere on Earth. The oxygen fraction is about a fifth, the nitrogen fraction is about 4/5. There are other things in there like argon's the next most common one, carbon dioxide's in there at unfortunately increasing concentrations. Now that is relatively the case all over the planet's surface, but of course there are going to be hot spots. I did my own experiment actually. We sent a balloon to the edge of space about 5 years ago, and we launched it near a motorway in the UK, downwind of a major city, and that was Bristol. The motorway was the M4 motorway. We had on our balloon some very sensitive sensors lent to me by my colleagues at the chemistry department at Cambridge University, so we were able to map the fraction of gases in the atmosphere as we ascended, and you could see a big plume, in other words a big increase in the amount of CO2 in the atmosphere as we went near the motorway and up over the city, and then it settled back to baseline again. So on the local scale, there will be differences. Where we have a big consumption of oxygen, you might see a slight dip in oxygen levels. Where we have big production of oxygen, you might see an increase of oxygen over oceans, near forests, for example. Where we have big sources of CO2, industry, fires, volcanoes, you might see there locally a slight blip in the concentrations. But because the planet's massive, the atmosphere is huge, the volume of the atmosphere is huge, the dilution effect is also huge. So therefore we have a stable atmospheric composition because there's so much atmosphere, and we are thankfully consuming only tiny amounts of the oxygen compared to the amount that we can produce, and we are only producing tiny amounts of CO2 normally, and most of those can be buffered by the systems around the planet that can soak them up or reverse the effect. But not totally, which is why we see this net surfeit of CO2, which is driving up the carbon dioxide level in the atmosphere year on year as we liberate carbon from fossil fuel sources.
Okay. We've got a voice note on earwax. Let's listen to that.
Good afternoon. I have a question for Dr. Chris. What is earwax? Where is it produced in the ear? For what reason? And then what makes the ear itch? Does it involve the earwax? Thank you.
Well, earwax, to give it its medical name, is called cerumen. And it is a waxy secretion or a fatty secretion made by oil-producing glands which are along the auditory canal and on the eardrum itself. And these glands basically take small amounts of material from the bloodstream and synthesize the constituents of the wax, which they then secrete onto the surfaces of the ear. And the purpose, because this stuff is sticky, is that it glues up things that would normally get into your ear and possibly lodge in there and cause a problem, dust particles and so on. It binds them up into little balls of this stuff and they then drop out harmlessly. Or when you splash water on your face, it just sort of rinses them out. It can be a problem in some people because it can build up pathologically. Because too much of it can form, it can be too sticky, it doesn't dislodge or come out, and it then blocks the ear canal up and sticks to the eardrum and stops it vibrating properly, so people can suffer decrement of hearing, and in some really serious cases they can develop other more complicated nasties that may even require surgery to fix them. There's one condition called a cholesteatoma, where you can build up material on your eardrum, which can then push the eardrum inwards into the middle ear and cause destruction of the bones that convey the hearing signals into your inner ear. But that's thankfully very, very rare. The composition of earwax is interesting because that differs according to where you come from on Earth. There are forms of the genes which lead to the composition of the earwax which are different in people from East Asia compared to people who are from, say, Europe. And this makes the earwax very dry in Asia and stickier in Europe. I don't know if it affects the flavour, though. I just think everyone agrees it tastes pretty horrible.
Let's listen to what Tom has to say about cars.
All these billions and billions of cars running around with the headlamps on during the perfectly good daylight hours, supposedly in the name of safety. But what a waste of energy, surely? Tom Midrand.
Hello, Tom Midrand. Well, it depends. If you work out what the energy cost of one car accident is, and I haven't done this, but I'm inviting, before we condemn or approve the procedure, this is really how we should approach it. If we work out how much energy we expend in terms of sorting out the accident, replacing the car that gets written off by the accident, getting the person to hospital, possibly in a helicopter, their stay in hospital, their borrowing a car while they don't have a car, etc., etc. Once you start taking all these things and the inconvenience and the cost, etc., into account, it begins to make quite a lot of sense to not have accidents at all. And what we do know from lots and lots of driver data now, and car companies, manufacturers, police, they have lots of data on this. We know that you tend to see fewer accidents the easier it is to see somebody. Whether you're a motorcyclist, big difference there, makes massive difference if you've got your lights on. Normal pedal cyclists, but also cars. And it does really make a difference. Although in daylight, yes, you're right, there's plenty of light around and it's easier to see things. What our brains are not very good at is seeing everything all at once quickly enough all the time. And if you have something which is making a slightly bigger dent on your perception, it can help you to catch sight of something just fractions of a second sooner and adjust your behaviour accordingly. And we do know this does work. And we do know that people do tend to have fewer accidents if they keep their headlights on, because it makes them just that little bit easier to see. So it does translate into fewer accidents. Does that stack up in energy terms, though? Well, you'd have to do the sort of calculations I invited you to do, which I admit I haven't done. I don't know if the manufacturers have. I suspect that, yes, there is an energy cost, but then what's the energy cost of the lock on your house? That we spend a lot of money on metal to put that lock there so someone doesn't come and burgle your house. Well, you could say, well, what a waste of energy. Let's just leave the house open. I might get burgled. There's a cost to that. And it's the same with the cars. Making yourself at lower risk of an accident has fewer human costs, energy costs, and also economic costs in terms of car replacement insurance and so on.
I think when you put it that way, everyone's going to be switching their lights on. Let's listen to what Thee has to say.
Good afternoon, Jane and Dr. Chris Smith. My question is with regards to the North Pole. So my understanding says if you were to walk around the North Pole, that means you've walked around the world, basically. So, now I just want to understand, how does time work when you are that close to the center of the Earth, if I may put it that way? Because I'm assuming an hour in South Africa cannot be as long as an hour in the North Pole. Um, I just I don't know. That's what I'm trying to figure out. How does time work at the North Pole?
You're
Thank you.
absolutely right. And it is very confusing. But here's how to think about it. Imagine we've peeled an orange and the orange is in segments. And round the girth or the middle of the orange, that's the equator. Let's say that's where Africa is. And as we go north up one of the segments converge towards the top where the stem is, the bit where you stick your finger to peel the segments apart. That's the North Pole. And you're quite right that those lines, the segments, get narrower towards the top. Now, why am I making a thing about these segments? Well, we divide the planet up into lines of longitude, and we notionally count Greenwich in London as naught because that's where they invented the scale, so they thought, let's start there. And every line of longitude is a certain number of minutes around the Earth's surface, a certain number of degrees, and then a certain number of minutes. And that equates to a certain number of minutes in physical time, when you count time. So if you know how many lines of longitude around the planet you are, you can work out what time it is in hours ahead of Greenwich or behind Greenwich. If you go to the North Pole, though, they've all converged into one place. So you can literally go around the world in under a minute. You're quite right. But luckily, not many people at the North Pole having to contend with that difficulty because it's relatively unpopulated. But you are quite right. And this is why it was such a headache for people who were going on the first major maritime journeys, because we can work out how far up and down the planet we are, latitude, from the equator, going upwards or downwards, because those lines are evenly spaced across the planet's surface. So you can work that out relatively easily. But longitude is a big problem because depending upon where you are up and down the planet and how far around the planet you are, those lines are different distances. So calculating them is not so trivial, which is why they needed accurate clocks. And that's where the whole clock conundrum came in about the 1700s, with James Harrison solving the clock problem by coming up with a clock that could keep accurate time at sea. Because once you knew how far around the planet you were, because you could work out what time of day it was, therefore where the stars should be relative to you, and therefore what time it was and where you were on the planet's surface, then you could navigate much more accurately. But this was a perennial headache until James Harrison came up with that clock that would solve the longitude problem, as it was dubbed, and a big prize was offered to the person who solved it, which went to Harrison.
I can imagine. David wants to know why strong perfumes, smoke, and dust cause sinuses, nose congestions, and headache.
Well, we breathe things up our nose, and they interface with the olfactory system at the top of the nose, and that's how we smell them. That's how we become sensitive of what's going up our nose. And they can warn us if there's something we're particularly sensitive to. But some of these smells contain a whole mixture of molecules that can actually irritate. They're not just smelly, they can also physically irritate. And some people, they irritate more than others. And when they irritate, what you're doing is causing inflammation in the nasal lining, and that inflammation causes the release of histamine. It makes your nose passages tickle and itch. And that was the other question I forgot about the ear. Why do your ears get tickly? It's the same phenomenon. That was the one, you see. We've remembered it.
Well done.
The reason it gets itchy is because of the release of histamine, and your ear is connected to the back of your throat through your eustachian tube. So if anything goes in your airways and makes its way to your ears, pollen, that kind of thing, it will make the inner sides of those tissues irritate and itch. You secrete some histamine. This makes swelling happen, so you get stuffy. It also makes more secretions happen, so your nose tends to run, and you get the urge to sneeze and clear your throat as well. So that's why.
All right, let's stay with noses. What causes nosebleeds time and again?
Well, in some people, there's a clotting problem. And people who have low levels of platelets, for example, people who have trauma to the nose, that's the other common one. Most ear, nose and throat surgeons will say when they're brought a little child to look at who says that they have got repeated nosebleeds, the first thing they do is pick up their hands and look at their index finger, because finger-related trauma to the nose i.e. picking the nose, is the commonest reason we get nosebleeds, because we traumatise the tissue up your nose. But the reason it bleeds is because the nose has a very rich blood supply. It's there to keep the air that's coming up your nose warm and wet before it gets into the back of your throat and then into your lungs. To get that warm, wet air, you need a rich blood supply. So the nose is relatively easily traumatized. And if you dig around with your finger, you will do damage. If you take certain drugs that we are aware of that you shouldn't be taking, they can damage the nose lining as well and cause bleeding. And infection is also a common reason. If you get certain viruses, for instance, they can irritate the lining of the nose and damage the tissue, causing small amounts of blood loss. But if you get regular, very torrential nosebleeds, you must get this investigated, especially if it's a new thing that you don't have an underlying diagnosis you're aware of. You must go and get that investigated, because there are some serious things that need to be fixed or investigated under those circumstances. So new torrential nosebleeds that you can't explain on the basis of I bashed my nose, trauma, picking your nose, recent infection, that kind of thing, those will all resolve on their own. But new repeated phenomenon like this, do get it checked. Yeah.
Puli is on the line, calling us from Centurion. Go ahead, Puli.
Hello, Jane and Doctor. How are you?
Good, thank you. Go ahead.
Good. I'd like to ask the doctor. Doctor, sometime last week I had 1 cup of tea and 1 cookie. And apparently from this cookie there was an exorbitant amount of sugar. So my body, I believe it got shocked and I got a running stomach for 2 days or so. Then when I went to the toilet, supposed to push out the whole thing, it seemed a little impossible to the point that there was a bit of blood. Then later, I got a severe headache that eventually moved to my neck pain that now I'm stuck with over a few days. I can't even turn my head properly. I can't even sleep well. So I'd like to ask what causes that, doctor?
Well, obviously, I can't do on-air diagnosis, and I can't tell you anything personal about your own health. You must go and see your own doctor, because that's unethical. It's also unsafe, because obviously I don't know you, I don't know your medical background, and I can't take a look at you. But it's very common to get infections, which when they get into you can cause muscle aches and pains. And if you get sort of muscle spasm, that kind of thing, off the back of having felt not too well in the tummy department, there are some members of the family of viruses called enteroviruses that can cause some vague abdominal symptoms, but they also go around your body and affect muscles and also nerves sometimes, and the lining of the tissues around your brain, your meninges. They're a cause of meningitis. So it might be that you have an inflammatory effect from one of those viruses which has caused the muscle to spasm or ache as a result of that. But as I say, I can't really say anything more than very general things, because it wouldn't be safe for me to do that. So do please, if this carries on, go and see someone who can help you.
Okay, quick one from us here. We were talking about what irritates people, and it could be a little thing that makes you incandescent with rage. What's yours?
Well, leaf blowers when you're trying to record an interview. I actually have working with me a young lady called Nadine, who's come from Cape Town, and she's staying with us for a couple of months making programs with the Naked Scientist. She's normally a scientist at the University of Cape Town, and we went to interview somebody together on Friday, and all around this village you could hear this blinking leaf blower because someone was cleaning up a churchyard. And so I was saying to her, noises happen, but there are some things which really are my nemesis in radio, and leaf blowers are one of them. So a happy leaf blower, probably at the top of the list.
Chris Smith, always good to talk to you. Thank you.
Take care.